Welcome back. In the last video we designed a test scenario for withdrawal. In this video we're going to create a JUnit test case for that scenario. But before we do that, let's talk about what the essential elements of a good JUnit test case is. Okay, so you'll see here there's 5 essential elements that I consider are needed in a JUnit test case. We need fixtures, and that's constant data that's going to be input to the methods or the state to simulate the state of the system. Actions, which is a method you're going to call under test. We need to capture the results after we run our test. And the fourth one is we need to construct the results that we expect, which is different from the actual results. And sometimes that's quite complicated if it involves lists and collections. And the last thing is we need to assert that the expected results are the same as the actual results. Now, I expect all 5 of these to be on separate lines of code. Now, there's only one exception to that, and that's that if you're capturing return values, so we're capturing the actual results as a return value of the method we're calling under test. In that case, it has to be on the same line of code. But apart from that, try to put each of these 5 parts of a unit test on a separate line of code. And you can do that with local variables to temporarily store the values, and it makes it much more readable. You'll see that later as we'll be coding a JUnit test in Eclipse in this video. Now, what you don't want to do is put capturing of the actual results inside the expression of the assert, which is what many students do. So they'll have a query method like getBalance, and they'll have those methods inside the assertion. Now that is really bad for a simple reason, which I call the immutability rule. So when you're trying to test something or trying to measure something, it can't be changing. So you can't measure something that's moving, a moving target. You can't measure something that's changing its value. So in the context of unit tests, while we're performing a test, the state of the system cannot change, i.e. it has to be immutable. So if you don't follow this rule, there's a chance that you'll have a bug in your test, because if your query method has side effects that's changing the state of the system, for example, popping the top off a stack, then your test is invalid because the state of the stack is changing while you're trying to test it. So it's best just to separate these things out. The assertion should only be asserting local variables that are guaranteed not to change, and you store your actual and expected results separately in local variables on separate lines of code. All right. So let's start doing some coding then. Let's move these around a bit. Might get rid of this. Move that up. So what we're doing in this video is we're going to be writing the JUnit test code, and we'll just move this around a bit, make some space. Okay, so here's a more detailed version of those 5 steps, which I'll talk about later, and we'll move our test case scenario design that we did in the last video to there, so we have some space for Eclipse. Alright, so what I'm going to do is I need to create a new project. So we'll create a Java project, and we'll name it SEF JUnit. Okay, and what we need to do, we first need to create our application. We've only got one class in our application called account. We'll just create an account class. That's this one here. So as you know from the previous video, where what we're testing is customers can perform withdrawal transactions. We've got an account object and a couple of methods and a constructor. Okay, so we've got our account object. I like to put my braces on the following line, not on the left of the previous line, on the right of the previous line. Okay, so that's just my coding style. You can follow that if you like, but you don't have to. All right, so we need a get balance method, which is going to return a double. And what's wrong with this? Okay, sorry. Yes, we're not in an interface. We're just creating a dummy a dummy implementation of our application for testing purposes. And because it returns, it needs a return statement in there. And so for the purposes of this dummy application, we'll just return a balance of 0. So we also need a withdraw method. And that takes an amount. And we need a dummy body in there for that as well. And that's not going to do anything. We don't need to do anything in there. And lastly, we need a constructor. We should probably put that up the top for good style sense. Now it's going to take an initial balance, as we see here, initial balance double. And we need a type in there. And that should do that. That constructor should be done. Okay, so that's pretty much our dummy application. So all we're really doing here is defining the signature of the methods. Now I could have done this in an interface, which is probably what I should have done, but just to save time, I've just done it all in one account object, so I've got everything I need. Okay, so the second class I'll create is our JUnit test class. And we'll call that test account. Okay, so this is where the rubber hits the road. We're going to write our JUnit test. Okay, so what we've got. Okay, so our action is to call the withdraw method. We've got lots of fixtures to do and results. Now this is our little instruction book. So we need to simulate the state of the system in our fixtures, create constants for our parameters, call the method. We need to capture our actual results in local variables, and we'll need to have some constants for our expected results, and finally assert. Okay, so this is everything we need to do. Now I'm actually going to do this backwards. Now I've got a little bit of a cheat thing here, so I'll just put these comments in. I'll just copy this from off the side. Okay, so to give us some structure to our JUnit test code, these are the 5 parts. Now I'm actually going to do these 5 parts backwards. I call it programming backwards. So I know what I want to do in my test case is an assertion. Every test case must have an assertion. So we want to assert equals. And so programming backwards is a concept where you just make up stuff, variables or method names that you haven't got yet, and you worry about implementing them later. So what I want to assert is that the expected balance should equal the actual balance. That's the end result, or the end game of my test case. So all I have to do is now define what expected balance and actual balance is going to be. Okay, so the expected result, they're going to be doubles. Sorry, expected balance is equal to, well, actually it's going to be equal to our call. So if we look at this, our expected result is going to be it's going to be a query method, sorry. So our expected balance is actually, we're going to call the get balance method on account. So that's easy. So assuming we've got an account, we'll just call it account dot get balance. That should be it. Okay, now we know we haven't got the account, but we'll deal with that later. So what's the actual result going to be? It's going to be a double. Actual balance is going to be equal to, now that one is going to be equal to, sorry, I've made a mistake here. So our actual result is actually going to be this. Okay, so when we call get balance on the actual account, that's going to be our fixture. That's going to be our actual balance. Our expected balance is a constant. So based on our design of our scenario, our expected balance is $70. Okay, so, and it's a double, so we'll need 70.0. Okay, so your expected results should you, and that's going to be our actual. Okay, so what actions are we going to have? So we need to call the withdrawal method. Withdraw. And we're going to need some sort of an amount in there. I'm going to use a local variable again. Okay. Okay, so that's all good. Now, I think all that's left is our accounts object, which is our fixture. So that's going to be of type account, named account. And it's going to call the constructor a new account. Now, our constructor has an initial balance in it. And we'll use a local variable again for that, just for readability. So we'll need another variable here. Okay, so our initial balance according to our design, our test scenario, is initial balance is 100. That's going to be a double. So 100, and we're going to create an account, and then we're going to withdraw withdrawal amount. Now we haven't created withdrawal amount. So that's going to be a double. So our withdrawal amount, according to our plan, is $30. Okay. So I've got some sort of a syntax error here. I haven't created a test first. So nobody's perfect. Let's put this in a JUnit test. That might be useful. Let's call it test withdraw success. And paste that back in. Okay. Now we're getting an error here because we need round brackets. Okay, so we're getting an error because we haven't got JUnit 5, so we'll add the JUnit 5 library in. That should get rid of that error. This one needs a void return. Okay, so now we have a successful compiling JUnit test. So it's not compiling yet, but we need another import here for assert equals, and we'll use this second one, which is for JUnit 5. So let's put those imports you can see up the top there. So in JUnit 5, they're all referenced via this org.junit.jupyter. Okay, so now that's successfully compiled. So just to give an overview, we're creating a fixture, a new account with an initial balance of 100. Then we're going to call the withdraw method with an amount of $30. And then we expect our actual balance after that. We're going to capture our actual balance after that by calling the getBalance query method. Now we're going to construct our expected result, which is just a double, which is 70. We expect the balance to be 70. Then we're going to assert that those two things are the same. The expected balance 70 should be the same as the actual balance, and hopefully that's 70. Okay, so that's our JUnit test. So let's run it and see what happens. Save that, and we'll just click on here, run as a JUnit test, and it fails. Well, the test ran, so the JUnit test is working, but it's telling us that our application has failed this test, which is what we expected. And if we click on this and expand this, we'll see it says assertion failed. It got expected 70, which is what we said, but it got 0. It got 0 for the balance, and that's because obviously we were just returning 0 in the getBalance because we haven't implemented our application functionality yet. So that's all good. So it's failed, and we expected that. In the next video, we're going to do one more test case to cover all the functionality of withdrawing. So see if you can guess what that functionality is that we haven't tested yet. And I'll see you in the next video.